All right, so your quiz tomorrow is only over sections 2.4 and 2.6. All right, I highlighted at the top the stuff that you absolutely have to know. It's everything, but I wanted to bring it to your attention. You need to know how to find the average rate of change if you're given an equation. You need to know how to find the average rate of change if you have word problems. We're going to go over a bunch. You have to be able to describe transformations if you're given an equation. You have to be able to write the equation if you're given all of the transformations. All of this was in your web assign. And we need to know how to find odd, even, neither algebraically and graphically. So we'll go over those as well. So if you look at numbers 1 and 2. All right, Mrs. Glick, or Ms. Heron, her review, God bless you, her answers are posted in modules. I have them there. She writes hers in a little list, which is totally fine. I am perfectly fine with you guys just pointing and telling me things. But when you are describing the transformations, if you tell me it's a reflection, I need to know if it's over X or Y. If you tell me it's a vertical shrink or a compression, I need to know by how much. If you tell me it's a shrink or compression, I need to know if it's horizontal or vertical. If you tell me it's a shift, I need to know left or right how much, up or down how much, all right? That's describing the transformation. So if we look at number 1, I see 1, 2, 3, 4 transformations. I told you guys yesterday it might be helpful if you kind of highlight your function so you see what is on the outside, which deals vertical, and what's on the inside, which deals with horizontal. So that negative sign way out in front, what does that tell me?
Reflection over X.
Reflection over X. So you guys would tell me reflect over X. Reflection is not enough information. I need to know what axis that it reflects over. Again, Miss Glick wrote hers in a nice pretty list. You can do that if you want to. The next thing I come to is a 2 that's being multiplied out in front. What does that mean? What kind of a stretch? Good. You can tell me V stretch. And how much is it stretching by? S-T-R-T. So you can say vertical stretch by 2. It's not a negative 2. The negative is the reflection. So now I move to the inside. What does that plus 8 on the inside mean? Left 2. Good. It's a horizontal. It's different. It's left and right. It's opposite of what you think. You could put horizontal. Left 8. I have no idea why I wrote 2. Thank you. It's left 8. You're looking at me like, what? I was like, what? I was like, yeah, wrong number. What does the minus 6 at the very end mean?
Down 6.
Down 6. You could write an arrow. That's telling me that you know it's vertical and you know which way it goes, up and down or left and right. Again, you can write a little list if you want to. That's fine as well, but I'm totally fine with you guys just pointing. All right, look at the next one. Again, let's talk about inside versus outside. The stuff on the inside affects the x-axis, and it's always the opposite of what we think, so be careful here. I see a transformation there, 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 and there. There's a lot. Look left to right. But what does that 2/3 in the front tell us? What kind? Vertical shrink. You can tell me shrink or compression by how much? By 2/3. Okay. What about that 5 at the end? Up 5. Okay. You can get that stuff out of the way. Now let's look on the inside. What does a negative on the inside tell me? Reflect over Y. Very good. Good, guys. Sounds good. What does that minus 1 tell me?
To the right one.
To the right one. Good. All right. Now for $100,000.
Horizontal shrink by 4.
Horizontal shrink. Totally agree. Horizontal shrink
Oh, is it like 1/4?
by 1/4. Fantastic.
So shrink.
We think, hang on one sec. We think it's a stretch because it's a whole number, right?
Yeah.
But since it's horizontal, it's the opposite. So it's a horizontal shrink, and then what do you do with the number? You flip it. Andre, question? Or you? Sure. Does that make sense? Everybody okay? All right, so let's move on to these next 2.
Wait, so if there's a fraction, like if the 2/3 like was where the 4th was,
Be 3/2.
it'd be 3/2.
Yep, good question. Mm-hmm. All right,
So
now,
it'd be horizontal.
yep, if it was on the inside. Now, look at these next 2. These guys are not difficult. They appear to be a little more difficult than they are. I'm going to show you how I think the easiest way to write these equations. This is the exact same thing. You're just giving it in words. and you're going to write the equation itself. So the first thing I do is I identify what the function is that they're talking about. This is a cubic function, right? So get your equation set up. F of x, I know is here, and I know I have a cubic function that's set up like this. Because anything that has to do with left and right or horizontal goes inside those parentheses, right? And anything that has to do vertically goes on the outside. Now that you have it set up, let's just go through and see what it says. It says this function is reflected over the y. Where does a negative go if it's reflected over the y? On the inside. Perfect. Okay, keep looking. Vertically compressed by a factor of 1/7. Where does a vertical compression go? In the front, and it stays exactly like it looks, 1/7. Good. Shifted 3 units to the left. That's the super left because I spelled it wrong. 3 units to the left. That's +3. Where? Inside the parenthesis. Good. And then the last thing says 4 units down. -4 on the outside. Look how easy that was. Now what's the one thing we didn't write? The x. We got to stick it in there. You can write it at the beginning if you want. Very good, guys. So before you try and do everything all in one step, just kind of get your shell set up and plug in everything where it needs to be. Look at the next one. What is the function itself that we're talking about? What kind of a function is that? Square root. Okay, so I'm going to write g of x equals, and then I'm going to make a big square root. And I know that anything that has to do horizontally, left and right, or shrinks and compressions, horizontal goes on the inside, and anything vertically goes on the outside. So the first thing I come to is a reflection over the x. Where does the reflection over the x go? Outside, agreed. Horizontally stretched by a factor of 7. Ooh, look at you guys. 1/7 on the inside. Good. Horizontal stretches and compression goes on the inside, and it's the opposite of what we think. Now I have 2 units to the left. Where? Underneath. Make sure it's underneath that square root. And then I have 8 units up. +8 on the outside. You can put it way back there just so I don't have to guess. And then don't forget your x. But do you guys have any questions? You see how that works? You all good? Everybody good? Okay, look at the next one. These next two. The math behind this might get a little tricky, but that's not the college algebra part. That's like, algebra 1-ish with fractions and stuff, but you guys all can handle this. The first thing we need to remind ourselves, what is the average rate of change formula? Yep. y2 minus y1 over x2 minus x1. Whatever y you start with in the numerator, you need to start with the corresponding x in the denominator. So I could tell you between x equals something and x equals something. Or I could tell you to look between, like I did here, -2 to 3. I'm giving you the 2 x values you need. The first x value I'm going to plug in, we're going to evaluate where x is -2. And the other one we're going to evaluate is where x is 3. How do you find the y value if you already know the x? You just plug it in. That's it. So be careful. I have 2 times -2 squared minus 3/4 times, I'm going to write 2/1. Just because sometimes when we have fractions, we like to see them with numerators and denominators. Oh, I forgot the negative. Sorry. Thank you. So let's evaluate. What is -2 squared? 4. And then 4 times 2 is 8. Okay. Minus, what's -3 times -2? +6/4, right? When we have fractions, you just multiply numerators, multiply denominators. Now, everybody in here can figure out this problem. You need a common what? Denominator. What's a common denominator between 1 and 4? So if I multiply the bottom by 4, I get 4. If I multiply the top by 4, I get 32. Good. So what's 32 plus 6? So this happens to be 38/4. So my first ordered pair is -2, 38/4. Fractions are okay. Yes, sir.
You have to simplify it.
Okay, good question. You could simplify if you wanted to, right? 19/2. At some point, you have to simplify. I'm leaving it like that just for now, just because I know how the problem works out. You're going to have to get another common denominator, so. But yeah, you can go 19 over 2, and then you'll just have to get a common denominator in a second. So now when I plug in 3, we're going to do the exact same thing. 2 times 3 squared minus 3 over 4 times 3 over 1. 3 squared is?
9.
And 9 times 2 is? 18. This is over 1, right? Minus 3 times 3 is 9 over 4. All right, our math gets a little bigger here, but nothing you guys can't handle. What's a common denominator between 1 and 4? 4. If I multiply the top by 4, then I multiply the bottom by 4, vice versa. So 18 times 4 is 72. So 72 over 4. And then what's 72 minus 9? 63 over 4. So in this case, when I plugged in 3, I got out 63 over 4. Okay, I have an x value, I have a y value for both. That means we can find the average rate of change. I'm going to write 63 over 4 minus 38 over 4, right? Y2 minus Y1 over, since I started with 63 on the bottom, I'm going to start with 3 on the, on the top, I'm going to start with 3 on the bottom, so 3 minus negative 2. So what's 63 in the numerator, guys? What's 63 minus 38? 25 over 4 divided by 5 over 1. Yeah? All right, this is not college algebra. Keep, change, flip. We're going to keep, change, and then I flip. What happens to my 5s? Right? So my average rate of change between these 2 points is 5 over 4. That's it. You guys might have to get a common denominator and combine fractions. That actually might happen, but you will be fine. When you have a problem like number 6, same type problem. They gave you an equation. It's not in standard form. This makes it actually a little easier for us. I have between where x is negative 3 and where x is 4. So when you plug in, you just got to be careful with your signs, guys. You don't have anything to solve here. You're just simplifying. So when we simplify, we work from where? Not so much left to right. Inside, out. All right? So I have negative. What's inside my parentheses here? What's negative 3 plus 1? Negative 2 cubed minus 5. I don't suggest skipping a lot of spaces here, skipping a lot of steps, because you're going to miss a negative sign. The next thing I would do is what? No. What? Use your PEMDAS. Negative 2 cubes. So I have minus, negative 2 cubes is negative 8, minus 5. So minus a negative gives me a, so 8 minus 5 is 3. So when I plug in negative 3, I get out positive 3. Don't try and skip too many steps when you're simplifying, because you don't want to miss negative signs. So same thing here, guys. We're going to plug in positive 4. So negative, I have 4 plus 1 cubed minus 5. Work from the inside out. I have negative. What's 4 plus 1? Good. So now I'm going to cube. What is 5 cubed? 5 times 5 is 25 times 5 is? 125. Okay, so you have a negative, God bless you, out in front of that. Negative 125 minus 5 gives you negative 130. Okay, so when I plug in positive 4, I get out negative 130. Here's my x value. Here's my y values. Average rate of change. Your y is on top. Can I say 3 minus a negative 130? Sure. 3 minus negative 130. If I use 3 on top in the numerator, what do I need to start with in the denominator? Yep, negative 3 minus 4. 3 minus the negative 30 is negative 133. And then negative 3 minus 4 is negative 7.
Wait, isn't it then positive?
Yeah, my bad, sorry. Thank you. Now, some of you will leave that and just be like, okay, good. Does 7 go into 133?
Yeah.
Yes. If you don't know that right off the top of your head, you guys have to divide. So I'm going to say 133 divided by 7. 7 goes into 13 one time with 6 left over. Bring down the 3. 7 goes into 63 9 times. So you have negative 19. If it doesn't simplify pretty, just simplify the fraction as much as you can, and you can leave it as an improper fraction. But if it does simplify, you guys need to simplify. So questions about that first page? No? Pretty straightforward. All right. Go to the next one. Some of you are just following along with what Miss Glick did, and that's fine. It's totally fine. You can look back at this tonight. Odd, even, neither. Algebraically. If you just tell me odd, or you just tell me neither, and it's right, you're not getting any credit unless you show the work. So let's talk about how we go through to show the work. What do I do? What do I look at first? The highest exponent. What is the highest exponent you see? 3. Doesn't necessarily mean that it's going to be the first exponent you see. Look for the highest one. This is an odd number, so your function can either be odd or neither. Even is no longer a choice. So if you get your work set up, if you think this is an odd function, when you work this out, what should your answers be of each other? Opposites. Good. I would do this so you can see at the end, oh, they are opposites, or no, they're not. Now, you can plug in any number you want, and it's opposite, as long as it's bigger than 1. 2 and negative 2. 3 and negative 3. 27 and negative 27. Does not matter. You just have to use a number bigger than 1 and its exact opposite. If you want to use 2 and negative 2 every time, you're more than welcome to. It's not that you have to do 2 on one side and negative 2 on the other. It doesn't matter. You could do positive 2 first or whatever. But I would suggest putting everything in parentheses just so we don't miss any negative signs. So I have negative 2 cubed minus 2 times negative 2 squared. So as we simplify, guys, what is negative 2 cubed?
8.
What kind of 8? Negative 8 minus 2 times, what's negative 2 squared? 4. Simplify a little more. Negative 8 minus 8 gives me negative 16. Okay? Fine. Let's come over here with 2. Excuse me. So I have 2 cubed minus 2 times 2 squared. So simplify. 2 cubed is 8 minus 2 times 2 squared is 4. Simplify a little more. 8 minus 8 is 0. Are those two numbers opposites of each other? No. So what is your answer? Your answer is neither. You can just put a big N if you want to. But I have to see the algebra behind it. It's going to say determine odd, even, or neither algebraically. All right, let's look at the next one. How do I first determine where I should even begin? Highest exponent. What kind of a number is 4? Even. So I have 2 choices. It's even or neither. What number you guys want to use? 2 and negative 2, okay. So if I think this function is even, what should my answers be of each other? They should be the same. So I'm going to try negative 2, and I'm going to try positive 2, see what happens. So negative 3 plus 2 times negative 2 to the 4th power. Simplify your powers first. So I have negative 3 plus 2 times, what's negative 2 to the 4th power? 16, yep. So negative 3 plus 32 gives me 28, 29, 28, 29, okay. So on the right-hand side, we're going to do the exact same thing, but I'm going to plug in now positive 2. So negative 3 plus 2 times 2 to the 4th. Evaluate your exponents first. Negative 3 plus 2 times 2 to the 4th is 16. Negative 3 plus 32. What's negative 3 plus 32? 29. Is my answer here 29? No. The relationship between these two answers are the same. That means you just proved algebraically that this function is even. All right, that is how we answer those questions. Questions. If you have a fraction, if you have anything, nothing changes. You look and find the highest exponent. That is what you are looking for. All right, now we're going to look at word problems. Guys, you should be able to, what you're going to do with the word problem is you will find your X and Y values given the word problem. What you're going to do is identify two ordered pairs, two X values that go with two Y values, and find the average rate of change. You're looking for a dependent and an independent variable. I know you guys have seen that before. We still get confused. Write this down. Time is always X value. Time is always X value. Weight, a lot of times, is your Y value. But if we look at this first question, all right, I'm trying to extrapolate, trying to take out from this question two ordered pairs. So it says a climber is on a hike. After 2 hours, he's at an altitude of 400 feet. After 6 hours, he's at an altitude of 700 feet. What's the average rate of change? Well, the average rate of change, the longer he hikes, what? The higher he goes. So your height is dependent upon your time. So if you were going to write these two X, Y coordinates, what is the first one? 2, comma what? Perfect. What is your second ordered pair? 6, comma 700. So now let's think about this for a second. Your Y value is time. So your Y value, your X value is hours, your Y value is feet, right? Okay. So here's my X, here's my Y. So 700 minus 400 over 6 minus 2. You guys agree? Okay, so 700 minus 400 is just 300. 6 minus 2 is 4. And we always simplify if we can. Can we break 300 up into 4 pieces? Yeah, what is it? 75. And this is a word problem. That means I have to have a unit with my answer. What's on top? Feet or hours? 75 feet per hour. Good. Whatever's with the Y goes on top. Whatever's with the X goes on the bottom. That's good. All right, let's look at the next one. A diver's 30 feet below the surface of the water after 10 seconds. And then he's 100 feet after 40. What are my two ordered pairs?
10 and 30 and 40.
Okay, 10 is my time. 30 is the depth, right? So this is what, seconds? Seconds over here, feet over here. And then my second one is after 40 seconds, he's where? 100. All right, so the average rate of change. Somebody asked period. Why do you always put the bigger number first? You don't have to. I can say 30 minus 100, right? If I use 30 in the numerator first, what do I have to use in the denominator first?
10.
So 10 minus 40. Okay, what's 30 minus 100? Negative 70. What is 10 minus 40? Negative 30. So a negative divided by negative equals a positive. My zeros cancel out. I have 7 over 3. Does that simplify real pretty? No, you can leave it. Miss Glick went ahead and simplified it a little more, but you can leave it. But what is your unit?
73 seconds, 30 feet per second.
Feet are on top, seconds are on the bottom. Good. Very good. All right. A teacher weighed 145 pounds in 1986 and weighs 190 pounds in 2007. That's two ordered pairs right there. What is the ordered pair? What's the first one? 1986, 145. They weighed 140. The 145 was in 1986. This is the year, and this is the pounds. Your second ordered pair is 2007 and 190. Everybody with me? All right, so I'm going to say 190 minus 145 over 2007 minus 1986. You might have to write this down and do a little math. You guys will not have a calculator, so make sure you know how to do this. But what's 190 minus 45? Minus 45.
45.
Okay, 145, yeah, 45. And then what's 2007 minus 1986? 21. All right, does that simplify? Is there a number that goes into 45 and 21? 3. What's 4 plus 5? 9. What's 2 plus 1? 3. 3 goes into both. 3 goes into 45, 15. And 3 goes into 21, 7. Does that simplify any prettier?
No.
No. I mean, you could if you wanted to, but you don't have to. So what is my unit?
Pound per year.
Pounds per year. Your word problems should all have units with their answers. All right, look at the last one. Not meant to be tricky, but it says Michael has a savings account that he started $300 in. After 4 weeks, he had $350, and after 9 weeks, he had $400. What's the average rate of change?
$50 a week.
50. It is 50. Okay, but hold on. It's not 50 per week. I like where you got 50, but what is my first ordered pair? 4 and 350. Remember, time and then money. Here's my first time. That's what goes with it. What's my second ordered pair? 9 and 400. Does anything, or does 300 have anything to do with this problem? No. So here is my weeks, and here is my money, right? So 400 minus 350 over 9 minus 4. What's 400 minus 350? 50 over 5 gives me what? $10 per week. Actually, you can write it like this. I like where you saw 50, though. That was good. All right, so you're going to have a couple word problems where you guys are going to have to, you cannot come up to me and be like, which one do you want me to put for the X and the Y? That's what the word problem is for. All right, and lastly, everybody will have one of these. I just drew these to the best of my ability, so just go with it, all right? If you're going to determine odd, even, or neither algebraically, you use positive, -2, figure out if they're the same answers or opposites, right? If you're going to do this graphically, same kind of concept. If it's an even function, we know two things. The arrows go in what? The same direction, good. And has to do both of these things. Symmetric to y. What does that mean? Y cuts it in half, okay? If your function is odd, the arrows go in opposite directions, good. What else has to happen? And it has to go through the origin. Got to do both things. If it doesn't do both, it's neither. So you guys are going to say, how would I show work on this? Here you go. Same or opposite? Opposite, okay. What's the second thing that has to happen in order for this to be an odd function? Has to go through the origin, does it?
Yeah.
Yes, so your function is odd. Okay, direction of the arrows is the same, all right. What's the second thing that has to happen? The y-axis has to make the left-hand side the same as the y. Left-hand side the same as the right, does it?
No.
So my answer here is neither. Last one. Arrows are same, okay. Now pretend I did this perfectly. Does the y-axis make the left-hand side exactly the same as the right?
Yeah.
Yes, this is symmetric to y, so this is what kind of a function? There you go. There you go. You guys are going to have 10 questions, all right? You'll have the whole time. You'll have probably about 36 minutes or so. You're not getting any extra time. It's not 10 questions that are all average rate of change. You have probably 3 or 4 that you just have to look, identify transformations, write the equation, something like that. But this, if you know this, you know the stuff that we've gone over the last few days, you should be perfectly prepared for your quiz. Anybody have any questions? No questions. We're good? Okay.